Hi Year 11. Today we are going to stick with our quantitative chemistry topic and we are going to consider how to work out the percentage of elements in compounds. Now we are turning in our notes to page 131. Now we are going to use the relative atomic mass of the element. Sometimes you'll see this called the AR, but it is the top number in the periodic table. And we are going to use the relative formula mass of the compound in the question, and sometimes you see this called the MR, the molecular mass. Now, in previous lessons, we have already considered how to work out the relative formula mass, but we'll revise that in a moment. Now, the expression on page 131 is really important, and we've got to learn it. So the percentage of the element will be the mass of the element on the top line, divided by the MR of the compound in the question on the bottom line, and then because we're talking about percentages, we will multiply by 100. Now this will become easier when we look at the example in our booklets. We are asked, what is the percentage of carbon in carbon dioxide? So the question clearly asks me, what is the percentage of carbon? Now, if I look at the formula, that's the mass of the element on the top line. So I'm looking for the mass of carbon, the relative atomic mass of carbon. If we go to the periodic table, we'll find that carbon's top number is 12. Then I need to go and I need to work out the relative formula mass of this carbon dioxide. Now, we did it last lesson, like I've said, but just a quick reminder. We see in carbon dioxide there is one carbon. There are two oxygen atoms. So I go to the periodic table, I find carbon's top number. 1 times 12 will be 12. I find oxygen's top number, and 2 times 16 will be 32. Then I add it all together, and I will find that the relative formula mass, the MR for carbon dioxide, is 44. And that's what goes on the bottom line. Multiplying by 100 then, plugging it all into the calculator, we will find that the percentage of carbon in carbon dioxide is 27.27%. And I'm going to write my answer to 2 decimal places. Now let's take a look at a few more examples on page 131. And if we look at number 1 first of all. Now number 1 has been kind and it's given us some of the information that we need. We're asked for the percentage of copper in copper oxide. We're given the MR of copper oxide and we're given the AR of copper. Now remember, the MR is just another way to write the relative formula mass, and the AR is just another way to write the relative atomic mass. So I've given all the information that I need to use. The AR of copper on the top line will be 63.5, divided by the MR of copper oxide on the bottom, multiplying by 100 then, and I find that the percentage of copper in copper oxide is 79.38%. Now, sodium chloride then in number 2, we've got to do a little bit more working out. So the percentage of sodium in sodium chloride. Now I'm going to the periodic table and finding sodium's top number. And that's what goes on the top line. So sodium's top number, its relative atomic mass is 23. I've got a little bit of working out to do for sodium chloride. So in sodium chloride, there is 1 sodium, there is 1 chlorine. So I go and I find their top numbers, 23 for sodium, 35.5 for chlorine. I add them together and I find then that this comes out at 58.5. Pop that on the bottom line, multiply by 100, and we find that the percentage of sodium in sodium chloride is 39.32%. Now, if we do number 3 as a last example, we're asked to find the percentage of chlorine in hydrochloric acid. And the question clearly states what element we're interested in. So the percentage of chlorine is chlorine's top number on the top line. I've got to work out hydrochloric acid, HCl. So 1 hydrogen with a top number of 1 chlorine with the top number of 35.5. Add it together gives 36.5, and that's what goes on the bottom line. I'm multiplying the whole thing by 100, and I'll find then that the answer for this is 97.26. And like I said, leave your answer to 2 decimal places. Now folks, I'm going to be asking you to work through the rest of page 131, 132 and the couple at the top of 133. When we come to the extension activity, that's where we need to work out the formulas, the compound. And remember, we work out the formulas using this cross and drop rule. So I'm asked in number 16 for the percentage of sodium in sodium hydroxide. So the percentage of sodium in sodium hydroxide. Now before we can go any further, we've got to get the formula for sodium hydroxide. Up until now, we have been given the formula for the compound. Now your periodic table comes into play massively here. So sodium is in group 1, that means it has a valency of 1. Hydroxide is listed on the back of the periodic table. It is a molecular ion with a 1- charge, so its valency is also 1. When I cross and drop then, I find that the formula for sodium hydroxide is NaOH. Now you can use this then to go ahead and work out the percentage of sodium in sodium hydroxide. The next one is the percentage of potassium in potassium sulfate. Now folks, if you're super duper at this, you can be working out the formulas, pause the video and check that you've got it correct against my formulas. But I know that these can be quite tricky. So first of all, we need to get the formula for potassium sulfate. Potassium's in group 1, so it has a valency of 1. On the back of the periodic table, sulfate is listed as an SO4 2- ion, so it has a valency of 2. When I cross and drop then, I will find that the formula for potassium sulfate is K2SO4. The percentage of oxygen then in carbon monoxide. Now carbon monoxide, we need to know its formula is CO. The percentage of bromine in zinc bromide. So again, I'm using my cross and drop rule. Zinc is a transition metal, but it's listed on the back of the periodic table and it has a valency of 2. It forms a 2+ ion, so its valency is 2. Then we're looking for this bromide, which comes from bromine. Bromine is found in group 7, so therefore it has a valency of 1. Remember, the valency is the number of electrons that the atom needs to lose or gain. A bromine atom would need to gain 1 electron to get a full outer shell, so hence its valency is 1. So the formula for zinc bromide, when I cross and drop, will be ZnBr2. Now we don't need brackets here because bromine is a single atom. It's not a molecular ion. There aren't 2 capital letters or more than 2 capital letters, so we don't need the bracket. The last one then we're asked for is the percentage of lithium in lithium carbonate. And again, I need the formula for lithium carbonate. Lithium's found in group 1, so it has a valency of 1. Carbonate's listed on the back of the periodic table as a CO3 2- ion, so it has a valency of 2. When I cross and drop, I find that the formula for lithium carbonate is Li2CO3. Now folks, if you're able to work out those formulas yourself, you're doing really well, and it's worth investing the time to practice working out the formulas because it will stand you in really good stead. Remember, once you have the formulas worked out, you're not finished. you've got to go and work out the percentage of each of the elements that's asked about in the question in that compound.